All right, let's get into it. Welcome to what I'm calling a true hands-on masterclass for Terraform. Look, we're not going to just sit here and talk about theory. We are going to build a real-world enterprise-grade project for a FinTech startup together, right here and right now. I'm going to walk you through every single line of code, every command, and every best practice just like I'm sitting right there next to you, building this whole thing on your machine. My goal is that by the end of this, you'll go from just kind of knowing about Terraform to being a totally confident practitioner ready to build and automate real production systems. So what's on the docket today? Here's our game plan. We're going to start with the big why. Why does infrastructure as code even exist? Then we'll architect our project for a startup we'll call SwiftPay. After that, the fun part, a complete live build of their core infrastructure. From there, we'll go deep on the core concepts that really separate the pros from the beginners. And finally, we'll wrap up with production-grade best practices and get you totally prepped to crush any DevOps interview that comes your way. You know, before we write a single line of HCL, it's so important that we understand the problem we're actually solving. I mean, why does Terraform even exist? What was the pain point that was so bad it created this entire industry around infrastructure as code? This right here, this feeling is the exact reason. Imagine you're at a company that's growing fast. A developer needs an S3 bucket. Okay, fine. You log into the AWS console, you click, type some stuff, configure it, done. 2 minutes. But now imagine 100 developers ask for that same bucket. That's over 3 hours of your life gone, spent on mind-numbing, repetitive, and let's be real, super error-prone work. There has to be a better way. And this is that better way. The solution was a total mindset shift. Stop treating your infrastructure like a series of manual clicks and start treating it just like you treat your application, as code. You write the definition for that S3 bucket one time in a file. You check that file into Git, and now anybody on any team can run that code and get a perfectly identical, perfectly configured S3 bucket every single time. It's repeatable, it's testable, it's version controlled, it's automated. Now, what's kind of wild to think about is that before Terraform became the king, this problem was being solved, but in a really messy, fractured way. Every big cloud provider had its own IAC tool. If you were all in on AWS, you had to learn CloudFormation. If you were on Azure, you had to learn ARM templates. This meant that as a DevOps engineer trying to be multi-cloud, you were constantly learning completely new languages and workflows just to do the exact same thing. You were totally locked in.
And this is where Terraform just completely changed the game. HashiCorp saw this pain and had this brilliant idea. What if there was just one language and one workflow to rule them all? That language became HCL, and it lets you define your infrastructure for AWS, Azure, GCP, Kubernetes, even things like GitHub and Datadog, all from the same place with the same commands. This universal approach, plus a huge community building providers for everything, is exactly why it became the undisputed industry standard.
Okay, so lean in for this one, because this is a key interview tip. Terraform is API as code. What does that mean? It means when you define an S3 bucket in your code, Terraform isn't secretly generating a CloudFormation template behind your back. No, it translates your HCL directly into the raw AWS API calls needed to create that bucket. It's a native speaker. It's talking directly to the cloud's API, which is what makes it so incredibly powerful and flexible.
All right, enough talk. Theory's over. Let's get our hands dirty and dive into the real-world project we're going to build for our fictional fintech startup, SwiftPay. And this isn't some toy Hello World example. This is exactly the kind of foundational work you'd be doing in your first month on a new DevOps job. So here's the mission. We work for SwiftPay, a hot new startup on AWS. The problem is total chaos. Different dev squads are manually creating resources in the console, leading to this nightmare called configuration drift, where what's actually running in the cloud no longer matches what you'd think is running. It's causing security holes and wasting tons of time. Our solution? We're going to build a master Terraform project with reusable modules so any squad can spin up a complete secure environment with a single command. Now hold on, before you even think about writing that first line of code, we have to talk about project structure. This is absolutely non-negotiable for any professional work, seriously. Good organization isn't just about being tidy, it's the key to building infrastructure that you can actually maintain and scale without losing your mind. This structure you see right here is basically the gold standard used by top-tier DevOps teams everywhere. And this table just breaks it down perfectly. Let's look at the purpose of each file. We've got our core logic, our orchestrator in main.tf. We've got our inputs in variables.tf and our outputs in outputs.tf. Then we have these crucial configuration files. Provider.tf tells Terraform which cloud we're talking to, and backend.tf tells it where to store its memory, or its state. And then you see those directories, modules, and environments? That's where the real reusability magic happens. Don't worry, we are going to create and explain every single one of these. Okay, it is time. Time to get our hands dirty. For this whole next section, I want you to imagine you're opening up your code editor. I'm going to walk you through the complete code for our SwiftPay stack as if I'm sitting right there building it on your machine, and I'll explain every single line as we go. First up, provider.tf. This is always the very first file I create. That top Terraform block is where we state our requirements. We're telling Terraform, hey, we need at least version 1.5.0 view. But the really important part is inside required providers. We say we're using the HashiCorp/AWS provider, and we're locking the version to Sumo 5.0. That little tilde greater than is your new best friend. It's a pessimistic constraint, and it prevents a jump to a new major version, like 6.0, that could totally break your code. It's a lifesaver. The provider block below just tells that provider which AWS region we want to build in. Next up, backend.tf. And listen to me on this one, this is absolutely critical for any team bigger than just you. By default, Terraform saves its state file, its memory of what it built, right on your laptop. If you do that on a team, it's a recipe for absolute disaster. You'll constantly be overwriting each other's work. So instead, we set up a remote backend in S3. And see that DynamoDB table line? That enables state locking. It means when I run Terraform apply, Terraform puts a lock in that table. If you try to run it at the same time, it'll tell you to wait, preventing you from corrupting the state. It's like a do not disturb sign for your infrastructure. All right, variables.tf. This is how we make our code reusable and not a mess of hard-coded values. Notice that the environment variable has no default value? That's a deliberate safety trick. It forces whoever is running the code to explicitly say if they're building in dev, staging, or prod. Now, check out instance type. That's a map variable. It lets us define different server sizes for different environments right here, so we can just look up the right value in our code. It's super clean and really adaptable. Okay, let's dive into our very first module and see how these pieces connect. This is modules/vpc/main.tf. We're building the entire network layer here. First, the AWS VPC resource. That's our private, isolated network boundary. Then we create an AWS subnet for our public stuff. And notice that we set map public IP on launch to true. That's important. Next, an AWS Internet Gateway to actually connect our VPC to the internet. But a gateway alone doesn't do anything. It needs directions. That's what the AWS Route Table and the AWS Route Table Association do. They tell our subnet, hey, to get to the outside world, go through that gateway. It's a complete, self-contained network component. Now for our EC2 module. We're doing way more than just creating a server here. Check this out. First, we're using the TLS private key resource to generate an SSH key pair on the fly. This is a fantastic pattern that saves you from manually managing keys. Then we upload the public part to AWS with AWS key pair. Now, the most interesting part here are the provisioners. We'll talk about the pros and cons later, but for now, just see how they let us bootstrap our application. The file provisioner copies our app code onto the server, and Remote X runs the commands to install everything and start it up. And now we tie it all together back in our root main.tf file. This is the orchestrator, the conductor. And just look how clean and simple this is. We're not defining VPCs or instances here. We're just calling our modules like assembling Lego blocks. We call the VPC module, then we call the security group module. And look closely, we pass it the VPC ID from the first module using module.vpc.vpc-id. That syntax is the glue. Finally, we call the EC2 module, passing it outputs from the other two. Terraform is smart enough to see these connections and build everything in the right order. Every single Terraform project you ever work on will follow this exact 4-step dance. First, you open your terminal and type Terraform init. It'll download the AWS provider and connect to our S3 backend. Next, Terraform plan. This is your seatbelt. It's a dry run that shows you exactly what Terraform is about to do. You always read the plan carefully. Once you like what you see, you run Terraform apply. It'll show you the plan again and ask for confirmation. You type yes, and you watch the magic happen. And when you're all done, Terraform destroy tears it all down safely. Okay, we've built the project. That's awesome. Now let's zoom in and really understand the core mechanics. This is the stuff that separates the beginners from the senior engineers. The deep knowledge that lets you solve the really tricky problems. This is honestly one of the biggest aha moments for people learning Terraform. Resource versus data. It's super simple but incredibly powerful. A resource block tells Terraform, I want you to create and manage this. It's the builder. A data block tells Terraform, hey, go read some information about something that already exists out there that you don't manage. Think of it this way. Resource writes and data reads.
All right, let's talk about the brain of the whole operation, the state file. It's basically a big JSON file that acts as Terraform's memory. It's the map that connects the resources in your code to the actual real-world resources in your AWS account. It keeps track of every resource ID and every attribute. And it's what makes Terraform so fast, because it can just compare your code to this file instead of asking AWS about every single thing. Without the state file, Terraform has total amnesia.
Okay, I need you to listen very carefully. I'm going to say this once, and I need you to burn it into your brain. Never commit the Terraform TF state file to Git. Ever. First, it's a massive security hole. It can contain plain text passwords, API keys, all sorts of secrets. Second, it completely breaks teamwork. It's like checking your house keys and your credit card pins into a public library. Just don't do it. This is exactly why we use a remote backend from day one.
So why did we spend all that time creating that modules directory? Because modules are basically microservices for your infrastructure. Instead of having one single massive 1,000-line main.tf file, we break our architecture down into small, focused, reusable components. I can build that VPC module once, and every team in the company can use it. If I need to update a security rule, I just update it in one place, and everyone gets the fix. It's the only way to manage infrastructure at scale.
Now, let's circle back to those provisioners we used in the EC2 module. They seem pretty magical, right? And they can be, but they're also a bit of a trap. Even HashiCorp, the company that makes Terraform, says you should use them as a last resort. Why? Because if a provisioner script fails halfway through, Terraform can't easily undo it, and you're left with a broken server. For simple setup, a user data script is way better. For anything truly complex, you should be using a real configuration management tool like Ansible. Sooner or later, you're going to have to manage dev, staging, and prod, and there are two main ways to do it. You can use Terraform Workspaces, which lets you use one set of code but creates a separate state file for each environment, or you can just have different folders for each environment. Here's my rule of thumb. Use Workspaces when the infrastructure is identical, just with different variables. Use folders when the environments are fundamentally different, like your prod environment has a huge database cluster that just doesn't even exist in dev. All right, we've built a system that works. That's step one. Now for step two, making it bulletproof. This is the stuff that gets you hired as a senior engineer. This is how you build infrastructure that is secure, high quality, and totally automated. Think of this as your production security checklist. These aren't just suggestions. These are the rules of the road. We've talked about git ignore, but the others are just as critical. Always enable versioning on your S3 state bucket. That's your time machine if the state ever gets corrupted. Enable MFA delete on that bucket to prevent someone from maliciously or accidentally wiping it out. And that 0.0.0.0/0 SSH rule, in production, that gets locked down to your company's VPN IP range, period.
So how do you enforce all this stuff in the real world? You don't rely on people to remember. You automate it in a CI/CD pipeline. Imagine this. A developer opens a pull request with a Terraform change. Boom. A robot immediately runs Terraform FMT, validate, and most importantly, Terraform plan. And then it posts the plan output as a comment on the PR. Now your code review isn't just about style. It's about seeing the exact real-world impact of the change. Only after it's approved and merged does the pipeline actually run Terraform apply. That's how you do Terraform safely.
Okay, we've built the project, we've learned the theory, we've covered the best practices. Now, let's make sure you can walk into any interview and prove you know your stuff. And then, let's give you a clear path forward from here. Let's do a little pop quiz. The interviewer asks you, what is the Terraform state file, and why is it so critical? Here's your answer. The state file is a JSON record of all the infrastructure Terraform is managing. It's critical because it maps the code to the real-world resources. It's what allows Terraform to track drift, manage dependencies, and calculate what needs to change. Without it, Terraform has no memory of the infrastructure it created. Okay, here's another one. This one tests if you know how to work on a team. What is state locking? You say, state locking is a safety mechanism that prevents multiple people from running Terraform apply at the same time, which would corrupt the state. When you use an S3 backend in AWS, you also configure a DynamoDB table. Before Terraform modifies the state, it writes a lock ID to that table. If another process sees that lock, it waits, ensuring that all state operations are atomic and safe.
Let's just quickly go over the big landmines that most beginners step on. If you can avoid these, you are way ahead of the curve. Number 1, committing the state file to get. Number 2, hard-coding secrets or credentials. Number 3, not using a remote backend for a team project. 4, writing one giant monolithic main.tf file instead of using modules. And the scariest one, running Terraform Destroy in your production workspace by accident. Just internalize this list, and you'll save yourself a world of pain.
Look, watching this has been great, but doing the thing is what actually builds the muscle memory. So here is my challenge to you. This is your explicit action plan. This week, your only goal is to build the VPC and EC2 instance from scratch, just like we did. Next week, refactor that code into proper modules. In week 3, set up the S3 remote backend and practice the state commands. This roadmap will take you from the basics all the way to deploying a full application you can actually put on your resume. We have covered a ton of ground today. You literally have the complete blueprint now to go out and automate any piece of cloud infrastructure you can think of. You've got the code, you've got the concepts, and you have the best practices. The only thing left is for you to start building. So take what you learned, fire up your editor, and start automating. The journey to becoming a Terraform hero always starts with that very first Terraform apply.